Good morning. Welcome to episode number 20 of the ZOOMTOWN experiment. For today's video, we are going to wrap up our power supply and power distribution system. This video won't cover a whole lot of different things, but just wrap up all these loose ends. We're going to get all the components attached with interconnect wires using solder and crimp-on terminals. We'll assemble as much as we can. We do have some components that yet do not exist, such as the top deck and all of our logic information or logic components at the top end of the Zoomie. And finally, we'll set and test some voltage, and all of that will bring us into preparation for our final phase of the Zoomie assembly, and that is to take care of the logic components. We left off a few weeks back with this part of the assembly, and that is the power drive, and we'll have a power supply here, a motor drive, the motors, the wheels, all the sensors, etc. Now, normally I would build in order, but it's going to make it very difficult to show you what I want to show you. So I'm going to set this Zoomie aside, and we'll work with these components here, which is a near identical twin. Now, we've gone through a few episodes back. We built our battery tray to hold our 18650 batteries. Then we built this circuit board, which holds a couple of DC to DC converters that'll take our voltage from the 18650 cells and drop it down to both 3 volts and 5 volts that will feed up to the logic panel. Unfortunately, I just now found error in this design, and it's going to require me to run 2 wires into these tiny little screw terminals. I'm hoping that won't be a big problem because I've ordered this circuit board from a manufacturer already. So we're going to figure that out as time comes along and deal with the problems as they present themselves. We need to add a toggle switch for turning the power on and off, and then this particular switch really doesn't do anything with the power supply or distribution. It's strictly a logic switch where if I want something where I need to press a button and have the Pico W interpret a button press, that's what this switch would function as. We're going to be using the traditional jumper wires, DuPont on both ends. Of course, some of them will be cut off because we'll be either soldering or shortening and crimping on our own ends. And then we've got our standoffs. These are, I believe, 12 millimeter, and these are 16 millimeter. Now, I won't be wiring up our power supply today. We will save that for another time as we go through and get our motors wired up, etc. Getting all this done will probably take me a couple of hours, so I'm not going to, of course, bore you with all the details of that. As this plays out, I'll throw in some commentary over the top of it, and in other areas we'll just be fast-forwarding through, and we'll play a little bit of tune along the way to help make it a little more tolerable, if you will. See you in a little bit. One thing I'd like to go over real quick before we go into the rest of the details is a quick review of the schematic. This is the battery cell deck for our 18650 lithium-ion cells. This we did a few weeks back. The power distribution deck, well, we made the circuit board, but we didn't assemble the whole deck. That'll be what we're covering today. This is the screw terminal that I forgot to include in the system, which provides power down to the powertrain deck. That screw terminal would be feeding the raw voltage that's coming from the 18650. So I'll mention that again in a minute. But all we're going to do is just get voltage down to this power supply that's on the powertrain deck, and we'll deal with the rest of it later on in the assembly process. So this is about as far as we can go with the assembly, but we do have our battery pack area set. We'll test that out here in a little bit. We've got our power distribution area set, the momentary switch that is used as a digital input to our logic side. Really has nothing to do with power supply other than where it's physically located. Our main power on-off toggle switch is in place, as is our power indicating LED. Now you'll notice that I've got a loop here for the main feed wires that come up from the battery pack. That just makes it easier. If I take these 4 standoffs off, I can open this up and have a little more wiggle room rather than run those wires really short and tight. Eventually, this is the top deck, our logic deck, and this is what we'll be working on next. These wires here, this would be connected essentially right in this area, and these 2 wires would come around and connect over here. 3 volts coming in here, 5 volts coming in here, and then we've got 5 volts and 3 volts coming out that we can route elsewhere. And there is no sub-base to this one. The PCB will be the actual deck. As mentioning early on, these slots are to allow for guiding the wires up to the logic deck, all the way up to here. And as you can imagine, getting all of this routed up through those is still going to be a serious challenge. And then getting them all connected to the header pins that'll be on here. And as you can see, just with a few wires, it gets very cluttered. And if we had done this presentation with all these wires, it would have been a real nightmare to show you what's going on. So with this being as far along as we can get, we want to check our voltages and check out to make sure our switch and a few other things are working. To do that, I'll be using my meter, my VOM meter, if they still call it that these days. I'm going to hook an alligator clip over on the negative battery terminal, and that's also where I'm going to connect my bench power supply. I am going to then connect the bench power supply to the positive battery terminal, and then I have a probe here that I can use to probe for voltages. Now I'm going to turn on the bench supply, and it should be at about 7.5 volts. Okay, and what I want to do is check here. We've got our 7.5. My switch is off, and we've got no voltage. I'm just going to feel things, make sure I don't feel any heat anywhere. I'm not seeing any load on the power supply, so I can be pretty safe to assume we're not in a short. Now I'm going to turn on the power, and I'll watch my bench power supply. No current is showing. My yellow LED lit up, just very dimly. I don't want it very bright. It just becomes very annoying if that's the case. We've got our voltage there. Now this particular power supply should be outputting about 3.3 volts. And we got 3.42 volts. This power supply should be outputting 5 volts. It's at 5.1. Once everything gets put under load, those voltages will drop a little bit. Over here, I can gain access to the pins for the motor power supply, and that should be about 6 volts. It's at 6.4. Perhaps that's a little bit on the high side, but we will be drawing that down once a load is put on that motor. So I'll make a decision on that when it goes for final assembly if I should tweak that down. So right now, all our voltages look good. We have no heat, no magic smoke coming out anywhere, and I'm not drawing any serious current, so I think so far we've got a success. Well, I think that'll wrap it up for today. We've got our power source, our 218-650 cells that'll go in this location. We've got our power distribution system set up. We've got our power switch, indicator light, and our logic control switch all in place. We really can't terminate these wires until we have this circuit board populated and we start dealing with all the logic stuff. Moving on next is getting close to the fun time where we can start doing some programming and making this thing behave as a robot. We've got probably a couple of episodes yet on the mechanical building, and then we're going to turn our attention to the programming. So thanks for hanging around this long, and I hope you stick around for the rest of this crazy experiment we call the ZOOMTOWN experiment. Thanks for watching, and I look forward to seeing you in the next episode.